Hello students. In the last class we are looking at wireless protocols. So we have seen these things in the last session and we have started with RFID, radio frequency identification. We have seen how the RFID technology works and we have seen these points, and finally we have seen this classification. Okay, and today we are going to look at Bluetooth. So this is the logo or icon of Bluetooth. Maybe all of you have seen it somewhere. And so the standard for Bluetooth technology is IEEE 802.15.1. Okay, and initially Bluetooth was called as Bluetooth Basic Rate, or simply you can call it as Bluetooth, and it's a personal area network technology. Okay, so that is, the range of Bluetooth is less and it can be used as a personal area network technology, a wireless personal area network technology, because its range is short and it uses this 2.4 GHz frequency for transmitting and receiving data. Okay, and throughout time, that is history, there are several versions of Bluetooth. So initially there is version 1.0, then there is 1.0b, in which these features were added: voice dialing, muting the call, and it supported a range of 10 meters. Okay, so 10 meters means it is very less distance. Okay, and then there is version 1.2, in which this technique was implemented: adaptive frequency hopping. We are not going into very specific details, we are just seeing it as an outline. So if you are interested in any particular thing, you can find information about it by searching in Google. Okay, and then we have version 2.0 along with enhanced data rate, and then we have version 2.1 with enhanced data rates, and some other features that were included in this version 2.1 are: so improved resistance to radio frequency interference. Okay, so what is this radio frequency interference is? So in between the Bluetooth master and slave, I will talk about master node and slave nodes later. So in between them, in between the nodes, if some object comes in between, that is called as interference. Or if there is some other Bluetooth device, it might interfere with another Bluetooth device. That is called radio frequency interference. So this interference was reduced in version 2.1, and there is an improvement in the range. That is, the line of sight range is increased to 100 meters. So previously in version 1 it was 10 meters, so in this version it is increased to 100 meters, and the speed is also increased, fast transmission speed, and the power consumption was reduced. Okay, and then there is version 3.0, so there is enhanced power control in this version, and version 4.0, this is also called Bluetooth low energy. So this is important. So Bluetooth 4 is also called as Bluetooth low energy. So from this point onwards, Bluetooth or Bluetooth low energy refers to same thing. Okay, so from Bluetooth 4 onwards, it is also called Bluetooth low energy. Why? Because it takes less energy. Okay, So power consumption is less from version 4.0 onwards, and from this version onwards, the Bluetooth is used in IoT as a wireless technology. Okay, so why only from Bluetooth 4 means because IoT devices should consume less amount of power. Okay, most of them are battery constrained, right? Okay, and then there is version 4.1. So there is something called Piconet, that is the physical topology in Bluetooth. We will discuss in few minutes. So in this version there is better alignment in this topology. Okay, and version 4.2, still the energy consumption is reduced further. Okay, by using longer packet transmissions, right? That is by sending more amount of data in a single packet, so the length of the packet is increased. And version 5.0, so in this version there were some improvements in the mechanisms involved in transmission and receiving. Okay, and finally version 5.1 is released in January 2019, and version 5.2 is released in December 2019. So the latest version of Bluetooth or Bluetooth Low Energy is version 5.2. Okay, so these are different versions of Bluetooth or Bluetooth Low Energy. And if you look at the layers or the protocols which are used in Bluetooth, so the Bluetooth stack is compared against the OSI layers. So if you remember, OSI layers, bottommost layer, that is the first layer, is physical layer, and immediately on top of physical layer you have the MAC layer. Okay, so this is the Bluetooth's physical layer. Okay, Bluetooth's physical layer, and this is Bluetooth's MAC layer. Okay, so if you take TCP/IP model, this entire thing is the bottom layer, which is called link layer. Okay, right. So if you see here, there is in the physical layer you can see radio frequency, the baseband layer, which contains SCO. These are types of links, SCO and ACL. SCO is synchronous connection oriented, and ACL means asynchronous connectionless. Okay, synchronous connection oriented links and asynchronous connectionless links. Okay, that is the physical layer of Bluetooth. Now if you see the MAC layer, it contains two protocols. One is L2 cap and another one is LMP, link management protocol. We will see about each one of these things in the coming slides. Okay, as I have already told you, the physical layer of Bluetooth contains the RF, that is the radio, and the baseband sublayers. Okay, so if you see here, the role of radio layer is establishing the physical links among Bluetooth devices. Okay, so when Bluetooth devices connect with each other, how is the link established? Through radio layer. Okay, so it uses 79 different radio frequency channels which are spaced by 1 megahertz by using a technique called transmission technique called frequency hopping spread spectrum. Okay, so this technique increases the robustness of the link. Okay, robust link means that is even if there is interference, some kind of interference through other devices or other things, the data is sure to be transferred to other device. That is this robustness of the link. Okay, so it achieves this robustness by reducing the interference which is caused by nearby systems. Okay, right. Now we have classification of Bluetooth devices based on power. So you have classes here, class 1, class 2, class 3. That is Bluetooth class 1 devices, Bluetooth class 2 devices, Bluetooth class 3 devices. So for each class you can see what is the maximum output power and minimum output power. Okay, so you can pause the video and have a look at these things. And on the far end you have the distance for each class of devices. So if you see class 1 devices, the range of the devices is 100 meters. Similarly for class 2 the range is 10 meters and class 3 1 meter, very less, right? Small distance. Okay, right. So I have already listed these things and told you. So the standard is IEEE 802.15.1 and it operates in 2.4 gigahertz ISM band by using this technique, fast frequency hopping. And now coming to the MAC layer, so you can see the responsibilities of MAC layer, establishing the physical connections between the master nodes and slave nodes and sending and receiving packets along those channels. Okay, first it is establishing the connection and after that it is sending and receiving the packets from or to another device. Okay, and then synchronizing the devices with master clock. So in synchronous connections there is something called clock which will run on the master and the slaves are synchronized against that clock. Okay, so don't worry much about that, just remember this point. Okay, right. So if you remember in the MAC layer we have two protocols, right? One is this LMP, link management protocol, and another one is L2 CAP. We will see that in the next slide. So now let's look at this. So what is the role of LMP, that is link management protocol, is establishing physical layer links. So if you see here, the first role of MAC layer is this one, establishing connections, right? So it is done by link management protocol. Okay, so whenever the link is established, that is created, whenever the links are managed means that is creating the link and releasing the link. Okay, so those things are done by LMP. And if you remember, there are two types of connections, right? SCO, synchronous connection oriented links, and asynchronous connectionless links. So these links are managed by the link management protocol. Okay, right. So synchronous connection oriented links are symmetric, that is there is coordination between the master and slave node when they are communicating with each other, and they are called as point to point connections. Okay, point to point connections, that is one device to another device. So this link is dedicated link. Okay, point to point connection, right? Okay, so you can see here between master and a specific slave. Okay, right. So these SCO connections, these synchronous point to point connections are used to deliver delay sensitive traffic. For example, voice service. Okay, let's say you are using a Bluetooth headset, okay, for listening music or whatever audio, right? So if you want that to be delay sensitive, that means the audio must be smooth. There should not be any jerks when you are listening to audio, some kind of delay or latency. Okay, it should be continuous and it should be smooth. In such cases, we have to use these SEO links. Okay, so it is called circuit switched connection. So circuit switched connection means the path between the master and slave. This is dedicated link. Okay, no other slave will use this link to communicate with the master. Okay, so let's say this is slave 1. If it is slave 2, it will use another link. Okay, it will not use the same link as S1. So such kind of connection is called circuit switch connection. There is no sharing. Okay, and we have another kind of link, ACL, which is asynchronous connectionless link. Okay, this kind of link is called point to multi-point. So if you see this SCO link, point to point, this is one-to-one connection. Whereas if you see this point to multi-point, this is one to many. Let's say 1 to n. Okay, so point to multi-point connection. So this kind of connection is called packet switched connection. That means the same link is shared by multiple slaves. It is not a dedicated connection. The same channel or connection is shared by multiple slaves. Okay, and we will talk about Piconets in the coming slides. Don't worry, this is a topology which is used in Bluetooth. Okay, right. Now ACL, as I had already said, it is connectionless, right? And to ensure the integrity of data and to guarantee reliable delivery, that is without any errors, etc., it will use a scheme called automatic repeat request. Okay, automatic repeat request. So it is something like this. So whenever data is being sent through the channel, if there is any error in the data, then a request is automatically sent to the sender. That is like the data is corrupted, resend it again, something like that. That is automatic repeat request. Okay, so as I had already said, there is one more protocol in the MAC layer which is called L2 cap. So the abbreviation is Logical Link Control and Adaptation Protocol. So L2 means double L. Okay, so this refers to logical link. Okay, double L. So they have named it as L2, like two L's. Logical link control and adaptation protocol. So it provides channel based abstraction between the nodes. Okay, so it's an abstraction, it's not a physical thing, it's a logical thing. Okay, uh, so and it is between the baseband layer, which is a part of the physical layer, and the application layer. Okay, so the Bluetooth application will see channels. Okay, it will not see the physical links, it will see channel, and this channel will be talking with physical link. So it is a kind of what I can say, virtual, you can think like that, it's an abstraction. Okay, so that is okay, let's leave it with that. Right, and roles of this L2 cap layer, logical link control and adaptation protocol layer's role is uh, segmentation and reassembly of application data. Okay, so that is let's say, let's consider that audio example, you are listening to music. Okay, so let's say this is the song, whatever it is, audio, video or anything, as I have already told you in previous sessions, everything is represented in the form of bits, and okay, everything is represented as bits. And if you see this, um, typically one music file, let's say mp3 file, it will be of size 4 MB or 5 MB, right? But you can't send the entire 4 MB or 5 MB at a stretch using Bluetooth. So Bluetooth will be having some limitation, that is, it will have the packet size. So based on that limitation, let's say it is, let's say assume it has 50 bytes. 50 bytes. So this is the 50 bytes, it will divide this. Let's say this is one more 50 bytes, one more 50 bytes, like this. Okay, and so on. The file will continue, and the chunks will also continue, 50 byte chunks, and each chunk is called a segment. Okay, so this is segmentation 1, segment 1, segment 2, segment 3, and so on. Okay, so here the entire data or message is divided into different segments. That process is called segmentation. Okay, and at the other end, the receiving device will reassemble those segments. Okay, again combine them to create the actual file. Right, and this layer also handles multiplexing and demultiplexing of multiple channels. Okay, so these are the roles of L2 cap layer. So that is that, and one more point. So as a logical topology, Bluetooth will use contention-free token-based multi-access networks. Okay, it will use contention-free token-based multi-access networks as a logical topology. As physical topology, it will use something called Piconets and Scatternets, we will see in the coming slides. As a logical topology, it uses this, right? Okay, now see, the endpoint devices will act as slave nodes. Okay, slave nodes, or simply calling as we can call them as slaves. Okay, it is like this. For example, consider your mobile phone. Okay, so this is your mobile phone, and you have headsets. So this is a Bluetooth headset. Okay. Now in this scenario, your mobile phone becomes master and your Bluetooth headset will become slave. Okay, so here endpoint devices means in this scenario this is endpoint device. Similarly, if you look at laptop, okay, and let's say again you are connecting headset. Okay, and this time you have a mouse. Okay, this is a Bluetooth mouse. Just assume it is a mouse. Okay, and you have, let's say, a keyboard. Okay, so all these things are connected through Bluetooth, so it is wireless. Now in this scenario, your laptop becomes master and your keyboard, your mouse and your headsets will become slaves. Okay, so I think now you got a better idea what are these endpoint devices and what is this master and what are these slaves. Okay, right. And in Bluetooth we have a limitation, that is if you consider a master device, so this master device can be connected to only 7 slave devices. Okay, you cannot connect more than 7, that is you cannot connect 8 devices to a master, you cannot connect 9 devices to a master, it's a limitation. Okay, right. Okay, so now we will see some more points. So what is the responsibility of master? It will do something called polling. Okay, for authorizing a slave device to access the channel, and after accessing the channel, that is for sending and receiving data. Okay, so polling process is a sort of like voting process. Okay, right. And then uh, in Bluetooth we have something called Piconets, right? We will see in the next slide. And if you have several Piconets and if they are overlapping, it is called a Scatternet. Okay, both Piconets and Scatternets are physical topologies in Bluetooth. Okay, right. So when is this Scatternet formed is, you can see here, when at least one unit exchanges, in the unit means in the sense of slave. Okay, when a slave exchanges data with more than one master, okay, then the Piconets will overlap with each other and the resulting thing is called Scatternet. We will see in the coming slides with the help of a diagram, it will be clear, right? So what does Scatternets allow is, allows a slave to be active in more than one Piconet at the same time, but it can be managed by only one master. Even though it is active in 2 Piconets, it is managed by only one master. So the control commands will be sent by only one master, not both the masters in the in the 2 Piconets. Okay. Now size of Piconet is limited to one master and up to 7 active slave stations. Okay, this is a limitation which we have already seen. Okay, now Piconets. So two types of Piconets. One is single slave Piconet. You can see here there is only one slave and one master. So this is like a one-to-one topology, one-to-one connection, and this is one-to-many connection. So you have slave 1, slave 2 and slave 3. This is multi-slave Piconet. It is straightforward, right? Okay. Now this is Scatternet. Okay. So what is Scatternet? When Piconets overlap with each other. So if you see here, this Piconet 1 is overlapping with Piconet 2. Similarly with Piconet 3. Okay. So if you see here, this slave is communicating with the master of Piconet 1 as well as it is communicating with the master of Piconet 3. Okay. And if you see here, this particular node, it is playing a double role here. So with respect to Piconet 1, it is a slave, okay, in this Piconet. With respect to Piconet 2, this is a master node. Okay, so it is playing both the roles of slave and master. Okay, so since the areas of Piconet 1, Piconet 2 and Piconet 3 are overlapping, this entire thing is called Scatternet. Okay, alright. So I would like to mention one more point here. So let's say this is a room. Let's say your living room in your house. Okay. Now, if it is a normal Piconet, okay, can this topology be supported in a Piconet? Can you guess? Yes or no? The answer is no. A normal Piconet will not support this. What is the why? What is the answer? Why it is no? Because how many slaves we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So what did we see in the previous slides? So a normal Piconet will support only 7 slaves, right? But here there are 9. So this kind of topology is not supported with a normal Piconet. But what about Scatternet? It is possible, right? You can see here and on the slide. Okay, so that is the good thing about Scatternet. So we can utilize the bandwidth in a proper way, more efficiently using Scatternets. And also if it is limited area, we can connect more number of devices in a limited area with the help of Scatternets. Okay, right. So finally we will see the difference between Piconet and Scatternet. Okay, so the first difference, here in Piconet, device can function either as a master or slave, but not both. Okay, but in Scatternet, a device can function as a master, slave, or both. Okay, like this one. Okay, then Piconet. Sorry, this is serves. So serves smaller coverage area. Okay, and here Scatternet serves larger coverage area. So if you see this Piconet, its area is only this, but if you see the Scatternet, its area is the entire thing. Okay, and limitation of Piconet is supports maximum 8 nodes only, including 1 master node and 7 slave nodes. But here in Scatternet supports more than 8 nodes, like we have seen here. Okay, right. And last difference, in Piconet there is less efficient use of bandwidth. I already told you this. In Scatternet there is more efficient use of bandwidth. Okay, so let's review what are the things we have seen today. Okay, so we have started here with the standard IEEE standard 802.15.1, and I also told you that it's a personal area network, and it's a wireless technology which has very short range, and there are different versions. Okay, latest version is version 5.2, and we have seen the layers, Bluetooth stack with respect to OSI reference model, and then we started with the bottommost layers and the Bluetooth stack, that is the radio and baseband layers, and we have seen the classification based on power, and then we have seen the roles of MAC layer, and then we have seen some points about link management protocol, and we have seen two types of links, synchronous connection oriented and asynchronous connectionless, and then we have seen this L2 cap layer. We have seen some more important points about Bluetooth, and finally the topologies, Piconet as well as Scatternet, and the differences between Piconet and Scatternet. So that is about Bluetooth. In the next session we will look at Bluetooth low energy. Okay, some more details about Bluetooth low energy. Okay, that's it for this session. Thank you.